Hello, my name is Dr. Simon Schmidt. I'm head of the Department of Hygrothermics at the Fraunhofer Institute for Building Physics in Germany. Welcome to this video about the Lighthouse project at Chennai, where we discuss the energy efficiency enhancement measurements for the precast concrete construction system. By watching this video, I will show you how to enhance the energy efficiency by showing you some background about the energy efficiency itself, going deeper into the energy demand balancing, and also showing you how the steps are to reducing the energy demand in that special construction. And with that, I would like to start with the first step, with the basics of the energy efficiency in buildings. And the core basic is the definition of efficiency. What is efficiency and what are we looking at? And one common definition of efficiency is the definition that you can see here: achieving the best possible benefit with the least possible effort. In the building context, we therefore use some principles of energy efficiency in the building design. You can see them on the right-hand side in this graph. In the red squares, you can see different climate areas from the Arctic over the Mediterranean, hot and humid, hot and outer space. And for that, there are different measures that we take into our design process in order to enhance the energy efficiency. For example, in the hot and humid area, we look at the ventilation, we look at the radiation protection, we also look at the rain protection. And for the hot climate, for example, we look at the storage capacities of the building and also about the radiation protection. As Chennai is in the hot, humid or hot climate, we are looking firstly at these aspects. Firstly, I say because it's not just this, it could also be other aspects, for example, the insulation or the radiation protection as mentioned before. By doing that, we try to gather the benefits that are coming out of the energy efficiency measures that we have. First of all, it's the reduction of the energy demand during the use phase. We will reduce the energy demand for the building to enhance or to stay within the same comfort level. This could lead also into an enhancement of the comfort level, as you can see also in the benefits on the left-hand side, which is in another video. And this mostly also leads into the reduction of damages, which is also in another video. So in this video, we are going into the reduction of the energy demand during the use phase, which means we have to look into the energy demand. So what is energy demand? The energy demand is the balancing of the energy needed to hold a certain indoor climate. So the indoor climate is fixed, and we would like to reduce the energy we need in order to hold that indoor climate. And by saying that, we have to look deeper into balancing. What is balancing and how to balance the energy demand for a building? We can do that by different ways. And the simplest way is I have brought to you, so you can use that in your day-to-day work. The balancing background is always that we look at a system, for example, a building system, as you can see on the right-hand side, and we balance all the incoming energy, all the sources, with all the outgoing energy, with all the sinks, we call them. As you can see on the right-hand side, there is a lot of arrows pointing from the outside to the inside, or from the inside to the inside, or from the inside to the outside. This is what we want to balance. And if we do so, we can put up an equation, as you can see it here, and say what is, in our case, the sinks and the sources. Starting with the sources, you can see in your premise, in Chennai, solar gain is definitely a source, which is coming from the outside to the inside. So we put that on the left-hand side where the sources are. Then the second one is also the internal gains. People inside which occupy the building, which occupy the flat that we are looking at, but also the technical devices that are inside, TV, screens, computers, lighting, heating from other sources. And these are also sources because they bring in some energy to the system. And then on the other hand side, we do have the sinks, where the energy is going out from the system. One of the sinks could be the heat transmission through the envelope somewhere to the outside, but also to neighboring areas. The second thing could be the ventilation. If we exchange the air from the inside to the outside or to other spaces within the area, it is a heat sink. And then, if that's not enough and we need more energy out of the system, we can also add here the cooling demand. This cooling demand in the end will be the energy demand that we would like to diminish as far as possible. If you look at the right hand side, you can also see one arrow pointing from a radiator to the inside. This is the heating demand. I have marked that out because we do not need that in Chennai in the balance. If we have to put it into the balance, it's also a source, which is then on the left side. By calculating all the areas that we have, the solar gain, internal gain, heat transmission, ventilation and cooling demand, we can calculate the equation and see how big the energy demand is. To display what is actually happening there, I have put you a graphical display of this equation here. So we have on the left hand side the internal gains and the solar gains according to the calculations in their area, and we see that the solar gains are much higher than the internal gains, which is normal. But we see also on the left hand side there is a quite high column that we have. On the right hand side, on the sink side, we see the heat transmission sinks and the ventilation sinks add up. But we see there is still a gap between the left sources column and the right sink column. And this gap is then to be reduced or to be added by the cooling demand. This would be the cooling demand that we need for this balancing example. And this is the energy that we have to put into the system or that we have to evaluate out of the system in order to have a balanced temperature within that room. So far for the balancing basics and the theoretical areas. Let's move forward to your special area, to your Chennai area where you build the flats and how to really reduce the energy demand for cooling there. What I have done here is making an example for you. You can see on the right hand side the flat that I've introduced and that I've looked at. One flat which is singled out, and for that flat I have added all the balancing examples that you can see, or the balancing equation that you can see above the columns that we have. It's the same as we have seen before. So we have on the left hand side the heat transmission as a source. We have the solar gains as a source, and we have the internal gains as a source, which builds the source column. On the right hand side we just have the ventilation as a sink, and all the other energy has to come from the cooling demand. So we have a quite high cooling demand on the sink side. If we look at that, the next step would be to say, okay, what is the main source that we have and how to reduce this source? In this example, I have calculated the solar gains without any shadowing device, which is not really good for that area, but to show you what is happening, this is the best way. So what I have done is I've calculated the solar gains without external blinds, for example. But we could introduce these external blinds in order to diminish the solar gain that we have on the left-hand source side. And if we do that, we can recalculate all the areas that we have, all the sources and all the sinks, and we will see what happens then to the cooling demand. So the next slide will show you what happens if you introduce external blinds and recalculate the solar gain that you have then. And I can show you like here, it's again the same balancing equation. It changes a little bit because we changed the solar radiation. We have introduced external gains, and if we recalculate all the sinks and sources, we will see that now also the ventilation is a source. What we see in addition is that the transmission is a quite high source, but not the highest one. It's the third one in the line. Then we see that still the solar gains are quite high, and also the internal gains are quite high. The ventilation gains is not too high, so we will not look at that. But what we see on the right hand side is that the cooling demand is diminished by almost 40%. So by just introducing or looking at the balance and reducing the solar gain, we have enhanced the energy efficiency by 40%. The next step now would be to look at the sinks again and see what kind of sink we can reduce at the next step. If we go through it, we could think of reducing the solar gains again. This would mean that we reduce, for example, the window size or other aspects of the window so that we can reduce the energy from the solar gains. Sometimes this is not possible, so we leave that as it is. Also, we could think of the next main source is the internal gains, which means we could reduce the internal gains by allowing just one person into that room or something like that. Also, this is not very practical because we cannot say if there's a flat, there can just be one person inside. So we cannot do anything about that. But we could look at the heat transmission. In that area, the heat transmission, we do have a lot of losses, or we do have a lot of energy coming from the heat bridges. The heat bridges are explained in another video, but we see there's quite a high potential in reducing them, or there could be a high potential in reducing them. And then we would recalculate what's happening if the reduction of that source of the heat transmission is in place and what kind of energy efficiency enhancement we gain then at the cooling demand. If we do so and look even further, we can see what kind of energy efficiency enhancement for that precast concrete construction in Chennai are in place. I summed it up for you. So first, we have reduced the solar gains. This means the cooling demand is reduced of about 40%. So the energy efficiency is enhanced by around about 40%. If we do the next step, as I indicated before, and look into the heat bridges, insulate them or doing other things to reduce the heat bridges, we can further reduce the energy demand by around about 28%. So we have again introduced energy efficiency measurement into the 28%. If you now think back at the first foil that I showed you, where the storage is also one of the huge points in a hot climate, you could think of exchanging the ACC blocks with some kind of other material. For example, using bricks, normal bricks, which have a higher density, which have a higher storage capacity. If you do that in that area, you will see that the change in the material using bricks will increase, I repeat, will increase the energy demand about 13%. So you will not make a better energy efficiency, but a worse energy efficiency. So my point here is that you have to look closely at all the points. You can start with the ones I've showed you in the first slide, but you can also go into other directions, and you also have to go into other directions. But the steps, as I've introduced to you, are first calculating the balance, see where the main source is, try to reduce this source, and go again into the balancing. Look for the balancing, go through the balancing, say what is the highest source that we have here, and reducing this source if possible, and if it's not possible, go to the next highest source and reducing this. So this will lead you to the best energy, or to the energy efficient building in the end. And so you can really reduce the cooling demand for Chennai further and further. And with this, I thank you for watching this video and hopefully see you again at the next video. Goodbye.